idea of a sequence, which is just a list of numbers that follow a pattern. We are now going to go to the idea of a series. So a series is, instead of having 7, 15, 23, where we're just interested in individual parts, now we're looking at, well, what happens if I start to add the numbers? So in this case, the first sum of the first term, or S1, would be 7. S2 would be 22, 7 plus 15. S3 would be 55, 7 plus 15 plus 23, and so on. So when they ask us to find sum of 15, they don't want term 15, that's why it's not T15. They want to know what would the sum or the addition of the first 15 terms in this pattern be. Now, technically you could list out 15 numbers and add them, but that's time consuming and the chance of making a mistake is great. And plus, sometimes you could be looking for the sum of 3,000 numbers when it's just not very efficient at all to do it out long way. Luckily, we have two formulas to find the sum of an arithmetic series, and this is arithmetic because we are adding 8 each time. So I still have a common difference of 8 and a first term of 7. So A and D remain the same whether we're talking about a sequence or a series. So the two formulas are Sn equals n times the first term T1 plus the last term Tn divided by 2, or Sn equals n divided by 2 multiplied by 2a plus n minus 1d. This formula you only use if you know what the last number in the list is. So if I knew what term 15 is, I could find term 15 using a formula, but that's a lot of work. I like to take the most direct route. Because I know n is 15, a is 7, and D is 8, I have all the information I need for the second formula, so that's what I'm going to do. So the sum of 15 is 15 divided by 2 times 2 times 7 plus 15 minus 1 times 8. And I'm going to start to do some math. I like to clean up the brackets first. Now this is going to be 14 times 8. So I'm actually doing the 15 subtract 1 to think about it as 14. And then I'm going to go 14 times 8 to get 112. 14 plus 112 is 126. So now there's a couple ways to do this. You could think about it as a fractions where the 126 is over 1. You really don't need to do that though. I'm just going to go 15 times 126 divided by 2. And the answer is 945. What's important to note is that 945 won't necessarily be a number that we see in this list. 945 is the answer that we get if we add up the first 15 numbers in the list. So now we're going to work with a little bit funkier series again. So my first term is 5x plus 1. My second term is 3x. My third term is x minus 1. You might recognize from an example we did earlier where a is 5x plus 1, d is negative 2x minus 1, and again we are looking for sum 15 because that was the instructions for all the parts for number 1. So that tells me my n is 15. I don't know what Tn is, so I'm going to go back to the little bit longer formula, but it's really not a difficult formula to work with. So I get 15 over 2 times 2 times 5x plus 1 plus, now I'm going to get a little bit brave, and instead of going 15 minus 1, I'm going to go right to 14. So again, I'm getting comfortable with the idea that n minus 1 is always just 1 less than that, and my d is negative 2x minus 1. I'm definitely going to be cleaning up this bracket before I do anything. So I distribute the 2 into the first bracket. I distribute the 14 into the second bracket. Now I'm going to collect up like terms, so I'm going to get negative 18x, 10x, subtract 28x, and I'm going to get minus 12. And now I could look at 15 divided by 2 as 7.5. I've mentioned before, I think that I don't particularly like decimals. You could change that to 7.5 and send it in. I'm going to send it in by simply going times 15 divided by 2. So I'm going to do 15 times 18 divided by 2. I know the answer will be negative. So I get negative 135x. And then I'm going to do the same thing over here. So 15 times 12 divided by 2 to get 90. I know the sign will be negative. Another way to do that is to do the division by 2 first. Go 15 divided by 2 doesn't work very well, but 18 divided by 2 does. 18 divided by 2 is 9. 15 times 9 is 135. 12 divided by 2 is 6. 15 times 6 is 90. So however you get it, that's what I would get if I added up the first 15 terms and collected the x's together and the constants together. This is not necessarily a term in the list. Instead of being given the actual series in this case where we can say see our A and our D, we're back to being given two terms. So you might recognize that this is the exact same example we did before. So we have already solved for A and D. I am going to run through it a little bit more quickly though, just to remind you how to do that. And hopefully you're becoming more comfortable with the math. So as I work through this, it makes even more sense the second time around. So I make up my two equations from the two pieces of information. In this equation, I decide that it's quite easy to isolate A, so I do that. I'm going to sub in the other equation. So instead of A, I'm doing 39 minus 4D. I get 7D equals 49, or D equals 7. I'm going to sub in order to find A. So A becomes 39 minus 4 times 7, which is 11. So I have my A equals 11, my D equals 7. This is still question 1, and they're looking for a sum of 15. So that tells me N equals 15. I'm going to go to the longer formula because I know A, D, and N. And now it's just a matter of filling in. 2 times 11 plus 14 times 7. Again, I didn't go 15 minus 1. I actually did it and put it in. 2 times 11 is 22. 14 times 7, I believe, is 98. I'm going to double check that before we move on. Yep, that works. So now I have 15 divided by 2. Again, you could write that as 7.5. I prefer to wait till the end. And I get 120. So now this is going to equal 900, either by going 15 times 120 divided by 2, or 120 divided by 2 to get 60, then times 15. So the first 15 numbers in this arithmetic series would add to 900. Find the sum of negative 11, negative 1, 9, 19, 159. So now I actually know the last term in the list. So I'm going to show you how to use the other formula, n times t1 plus tn all over 2. Now t1 is just another way of saying a. So t1 in this case is negative 11. Tn is 159 all over 2. Ignore that mark there for now. I put that there by accident. In order to use this formula, though, we need n. This isn't part of question number 1, so this isn't the 15th term. We don't know what term this is. So I have to go back and figure out what n goes with 159 if A is negative 11 and D is positive 10. These are going up 10 each time. So 159 equals negative 11 plus n minus 1 times 10. You could put the 10 in. I'm going to actually bring this over and add it first. So I get 170, 159 plus 11 equals n minus 1 times 10. I'm going to bring the 10 over and divide it because it's a multiply here. 170 divided by 10 is 17. Now I'm going to bring the 1 over and add it. So I know that there are 18 terms. So really I'm looking for the sum of 18. And now that we know n is 18, you have a, d, and n. So if you wanted to, you could go back to this formula. It's a little longer, and I wanted to show an example using this formula, so I'm going to stick with this over here. So I get 18 times 148, all divided by 2. Easiest way to do that in your calculator is just to go 18 times 148 divided by 2. You could also go 9, because that's what 18 divided by 2 is, times 148. That's what I'm going to do because it's less buttons, a little bit quicker. It equals 1,332. So if I add up all these numbers, including the ones that I don't see in the middle that continue the pattern, the answer would be 1,332.